So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is minimum operations to reach target array. So you are given two integer arrays nums and target, each of length n, where nums of I is the current value at index I and target I is the desired value at index I. Now you may perform the following operation any number of times. So you can choose an integer value x, find all maximal contiguous segments where nums of I is equal to x, and then they have said a segment is maximal if it cannot be extended towards its left and towards its right while keeping all values equal to x. Now what they are saying is that you need to choose some value x and you need to find all the maximal contiguous segments. Now what is maximal contiguous segments? A maximal contiguous segment is a segment in which all values are equal to x and you cannot further extend this segment to right or left such that there is some value x present continuously or contiguously. So this is what maximal contiguous segment is, what they have defined. Now for each segment L to R, update simultaneously nums of L equal to target of L, nums of L plus 1 equal to target of L plus 1, and so on and so forth up till nums of I equal to target of R. Now in the end you need to return the minimum number of operations required to make nums equal to target. So what the question is saying that first you need to select some value x, it can be any value, and then you need to select all the maximal contiguous segments. Now these segments can be more than one. So in one operation first you need to select all the maximal contiguous segments which has these value x. So here it will be value x. Now in between there might be some values 1 2 3 whatever, here also might be some values, here might be some values. Now again here we have value x and x. Now what you need to do, you need to update all of these value in one operation to their corresponding target value. So whatever the target array would be, so whatever their index would be, let's say it is I, then it is I plus 1, then you may say it is j and j plus 1. So in the target array, whatever this I value is present is I plus 1 value is present, this j value is present, and this j plus 1 value is present. In one operation you need to just update these value to their corresponding target value, and in the end you need to return the minimum number of operations required to make the entire array equal to target array. So this is what you need to do. So let us see the examples and try to find out how will we find the solution for this. So in this first nums array is given as 1 2 3 and target array is given as 2 1 3. So you can see here this value is not matching with this. So okay, we can say that okay, we need to update this one value to 2. Now there is no one contiguously present in this, so we will consider the maximal contiguous segment to be this one only. So in this segment we will update all the values to this corresponding 2 values. So in this only one value is present, so we will just update this 1 to 2. So even if there was multiple 1 present and there was some 2,3 value present, so we will update this 1 to 2 and this 1 to 3. So this is what the question is trying to say. So in this case we will update this one value to 2, so we will require one operation. Now we move on to this index. Now we have the value 2. Now this is again not matching with the target value, so that means we need to consider this segment and we need to find the maximal contiguous segment. Now in this right and in its left there is no value which is equal to 2 which is contiguously present, so this will be the maximal contiguous segment for this part. Now we need to update this 2 value to 1, so this will take one operation. So till now we have 2 operation, then we will come at this index 3 or this value 3. Now this value is equal to the target value, so there is no point in using the operation because this is already equal, so we won't do anything and we have finished our iteration. So in this total 2 operations we need to perform, so we have the output as 2. Now let us take second example also. So in this question you will just understand what the idea is, what we are trying to build with these 3 examples only. Like that is how I come up with the solution during the contest. So your nums array is given as 4 1 4 and target is 5 1 4. So in this the first value is 4, so 4 is not equal to 5, so we need to consider x value to be 4 and we need to find all maximal contiguous segments with value equal to 4. So this will be one segment, this will be another segment. Now you cannot extend this towards right or left to find more such 4s contiguously, and similarly you cannot extend this to right or left to find more 4s contiguously. So in this case we have two segments that we have till now. So in this we will convert all the values to their corresponding target value. So 4 will be converted to 5, so it will be converted to 5 and this 4 is already there, and even if there was some other value, it won't affect because this is kind of one operation only. This selecting the segment and updating all value to their corresponding target value, it will take one operation only. It doesn't depend on number of elements. If the number of elements is 2 or even if the segments are 2 3, it will just take one operation for this one x value. So in this case we have done one operation till now by converting this 4 value to 5. So we have converted this 4 value to 5. Now we can move on to this index. Now this index already has the value equal to target, so we won't change anything. Now we come across this index. Now this also has the value equal to target, so we won't change anything. So in the end we have performed one operation, so our output is 1. So let us see this third example now, and third example is the example where you will this will make more sense to you. So 7 3 7 is the nums and 5 5 9 is the target. Now first is the 7. Now this 7 is not equal to 5, so we will find all maximal contiguous segments with x value equal to 7, not 5, 7. So this is one segment and this is one segment. So we will update all their values to their corresponding target value. So 7 will be converted to 5, so this will be 5. This 7 will be converted to 9, so this will be 9. So in total we require one operation. Then we are coming to here. So this 3 is not equal to 5, so we need to consider this as the maximal contiguous segment and we need to convert this 3 to 5. So this 3 will be converted to 5. So we took one more operation. Then we come to here. This is already we have replaced 7 to 9, so we don't take any operation. So in total we did 2 operations, so the output is also 2. Now have you observed one thing here? It doesn't matter how many repeated elements you have. We are only cared about unique elements, unique mismatched elements. If we have the unique mismatched element, so that is our answer. So in this case if you see, our nums array was 7 3 7. Now the target was 5 5 9. So even though this 7, this 3 and this 7 were not matching any of this target value, so we didn't apply 3 operation, we applied 2 operation because this 7 is repeated. So in one operation we can convert this both of the 7 to their corresponding target value. So we need to find the mismatched element, but only the unique mismatch element. So what we can do, we can just keep a set and we can just keep track of mismatched element. So if current nums of I, let's say this is nums of I, is not equal to target of I, we will just push this nums value into the set, and in the end we will just return set dot size, because we are only pushing the mismatched elements inside the set and set will keep track of the unique elements. So in the end what we will have unique mismatched elements, and that is what we need to return. So we will return set dot size. So I hope you understand this problem. So let us see the code. So code is very easy. Just declare one unordered set, because here we don't need to do anything with the order, we just need to keep track of unique mismatch element. So I have declared one unordered set of I named it S. Then n is the num size. We are just iterating on the nums array and we are checking whether this nums of I equal to target of I. If it is equal, then it is okay, we can just continue our iteration. Otherwise just place this mismatched element. So this is the mismatched element into the set, and set will keep track of the unique element. So what we will have unique mismatch element, and this was our main goal to achieve. So this was our goal to achieve. So in the end, how many mismatched unique elements are there? We will get through set.size. So we can just return set.size to get the unique mismatched element, and in the end we are just returning that. So I hope you understand this solution. Thank you for watching.